Karthik, and Chaitanya. Let's get into the work. Here's the table of content of our project. So first, the problem statement, then the problem versus the solution, then the uniqueness of our project, then the working mechanisms, the components which we have used, and finally the conclusion. So let's get into problem statement. In India, agriculture consumes 70% of the pure water which is available for drinking and other uses. In that, 60% of water is wasted due to over-irrigation and many other factors. And 50% of agriculture fields depend on rain-fed irrigation. The second problem which we faced is manual labor dependency. Small and medium-scale farmers spend 3 to 5 hours daily checking soil and watering plants manually. And third, the energy and water wastage. Often, farmers forget to switch off the water pumps which they have switched on. So, which will ultimately result in energy wastage and water wastage.
Now let us analyze the solutions to the problem set. So our project uses soil moisture sensors that detect the exact amount of water of the plant and supplies only the required amount to the plant. This prevents overirrigation and also ensures uniform plant growth and improves the yield. The robot moves approximately using 15 geomotors and scans the soil and water only the dry area. This reduces the labor effort and helps the farmers in performing the repetitive jobs. Our project focuses on the SDG goals: clean water and sanitation, zero hunger, industry innovation and infrastructure, responsible consumption and production.
Now let's discuss the uniqueness of the project. The robot automates the soil moisture and irrigates only when needed. This helps to improve, save water and energy. It moves autonomously and provides obstacle using an ultrasonic sensor. Real-time data on soil, temperature, all it will display on the LCD. Built-in affordability, easy available components for farmers. This promotes sustainability and farming through automation and efficiency. So now I would like to explain the working mechanisms of our project. So we have pinned a picture of circuit design, and this is a working principle of the project. It first reads the data from the VHT sensor, the soil moisture and the ultrasonic sensor, then shows the values on the LCD display. Then if the soil is right, the pump turns on, and if the soil is wet, the pump turns off and moves forward. If the obstacle is detected, it stops the motors and checks for alternative routes and repeats automatically in a loop. Now let us see the components used for our project. We used Arduino Uno, control the entire system, read sensors and sends commands to motor and pump. Sensor that we used: moist sensor, DH11, ultrasonic sensor. Now let us see the actuators. We have used 4 DC gear motors which will make the robot move, and a motor driver which controls the 4 DC gear motors, and the water pump to pump water from a container. Then we have used an LCD display, HW and a lithium battery, a switch, and some other accessories like jumper cable and breadboards. So we would like to conclude the project. This robotic irrigation system may mark a new era in farming where intelligence meets soil, and by combining robotics, sensors and automation, it transfers every drop of water into smart irrigation, ensuring crops get exactly what they need and when they need it. The robot thinks, moves and waters independently, reducing labor, saving energy, protecting one of Earth's most precious resources, water. At the conclusion, we have found solutions for all the problems which
conclusion.